In this video, we will review the structure and the function of the heart. Let's start with the physiology, or the function of the heart. Its functions are twofold. One, the heart serves to take oxygen-rich blood from the lungs and pump it to all parts of the body through what we know as blood vessels. Two, the heart takes deoxygenated blood, or blood that is oxygen deficient. It is filled with carbon dioxide instead, and it takes blood from the cells of the body and pumps it to the lungs for excretion. So, what's the structure of the actual heart? Well, it is located in the center of the chest. So imagine the body. It's located right here where I'm starting, and it is about the size of your fist. It is made of cardiac muscle, and the rate at which your heart pumps is controlled by the brainstem in the brain, and it's completely involuntary. So the heart is actually a hollow organ. You can see it spliced in half here with 4 rooms. These rooms are also called chambers. 2 chambers on the top half of the heart are called the right atrium, okay, and the left atrium. Remember that to determine right and left, it's important to just put yourself into the page as if you are facing yourself in the screen. You're standing in the page, facing yourself. Okay, this will help you remember the right and left atrium, the right and left ventricle. So, what are the rooms on the bottom of the heart? These are called, like I just said, the ventricles. The right ventricle, which is labeled number 1 here, and the left ventricle. Okay. So, right atrium, right ventricle, left atrium, left ventricle. This will be important to remember. So let's trace the path of blood through the heart and to all parts of the body. You might want to follow my cursor with your eyes or your pencil or finger so that you know where we are. Starting with right here in the right atrium, we're going to say that 10 and 11, as we see moving up here, this is filled, and 9, are filled with deoxygenated blood. And this deoxygenated blood, lacking oxygen, enters the right atrium. And it's directed one way, into the right ventricle through a valve. With the pumping of the heart muscle, this blood from the right ventricle then exits the heart through the pulmonary arteries and heads into the lungs for gas exchange at the alveoli and out of the body. After we exchange carbon dioxide for oxygen at the alveoli, we return this oxygen-rich blood now back to the heart. Okay? And both of these paths end up at the same spot in the left atrium. So the left atrium just receives oxygenated blood. And so you can see on the left side of this heart, we've got all oxygenated blood. From the left atrium, we travel to the left ventricle through a valve again, and then out through and pumped out through a powerful artery right on the superior part of the heart called the aorta. Okay, so the aorta, as you can see, branches out to support needy cells in the top and bottom halves of the body, where blood is delivered to cells through capillaries. And as cells receive oxygen, it releases carbon dioxide, creating deoxygenated blood once again. This blood hitches a ride through the inferior, meaning the bottom half of the body, and then through the superior vena cavas, these major veins that pump blood, deoxygenated blood. I shouldn't say pump, they're kind of weaker than arteries are. And they travel back to the right atrium to be pumped once again back to the lungs. And the cycle repeats itself about 100,000 times per day. So what's that familiar lub-dub sound that your doctor always listens to in the fancy stethoscope that he or she has? Well, one thing that she is hearing is the opening and closing of valves between chambers of the heart. And they want to determine if there's an abnormality, such as a valve condition. These valves between the chambers of the heart are key to heart function and allow blood to circulate in only one direction. And that's important. So also, please understand there's really no such thing as blue blood. It's not naturally occurring in the human body. It's just colored or dyed blue for the purpose of learning and differentiating oxygen-rich and oxygen-poor blood. So let's just go through the path of blood just to review. We start with the right atrium, travel to the right ventricle, where deoxygenated blood travels through the pulmonary arteries to, pulmo means lungs, to the lungs. And then the lungs now have exchanged carbon dioxide for oxygen. Now we can transport this oxygen-rich blood back to the left atrium, the left ventricle, and from there travel through the aorta to all the body's cells. And once we've exchanged gas at all of the body's cells, we've collected them in the major veins all the way up to the biggest veins, superior and inferior vena cava. Good luck!